Welcome sa course na Fluid Mechanics. Solve tayo ng mga problems tungkol sa hydrostatic pressure. Part 1, problem number 1. If the absolute pressure in a tank is 140 kilopascals, determine the pressure or the pressure head in millimeters of mercury. Atmospheric pressure is 100 kilopascal and use density of mercury equal to 13,550 kilograms per cubic meters. So yung given, absolute pressure na 140, hahanapin kung ano yung equivalent pressure head in millimeters of mercury. So, denoted yun ng H and then mercury, so Hg. At given din yung atmospheric pressure na 100 kilopascals. So, absolute pressure equal yun sa atmospheric plus gauge pressures. At yung gauge pressure, dito sa problem na to, in terms of mercury, kaya pressure ng mercury. And then pressure equals sa gamma H or unit weight times yung pressure head na tinatawag. Yung unit weight dahil ang given ay density, so density times acceleration due to gravity g. At yung g na gagamitin, hindi nabanggit sa problem, so gagamitin natin is 9.81 meters per square second. So therefore, ito yung pressure in terms of mercury. So absolute pressure is equal to atmospheric, which is 100 kilopascals, plus yung gauge pressure. So therefore, gauge pressure ay 40 kilopascals. So 140 minus 100. Dahil nga yung gauge pressure, yun sa pressure in terms of mercury, so 40 kilopascals equals sa density ng mercury, which is 13,550 kilograms per cubic meters, multiply sa acceleration due to gravity na 9.81 meters per square second, times yung pressure head. Yung kilopascal, para ma-solve natin to, gawin na lang natin times 10 raised to 3. Tapos, yung kilograms times meters per square second, so Newton. Para yung mga unit na lang, so newtons tapos meters, kaya magiging sagot is in terms of meters. So multiply sa 1,000 millimeters, which is equal to 1 meters, para millimeters yung magiging final answer. Therefore, so 40 times 10 raised to 3, so exponent 3, so E3, 13,550 times 9.81 times yung 1,000, which is equal to, so pressure head in terms of mercury or millimeters mercury, 300.9204. Or pwedeng yung pressure is 300.9204 millimeters of mercury. Problem number 2. The structure shown is used for the temporary storage of crude oil at sea for later loading into ships. When it is not filled with oil, the water level in the stem is at B or at sea level. As the oil is loaded into the stem, the water displays through exit ports at E. If the stem is filled with oil, it is to the depth of C, determine the height H of the oil level above the sea level. So use density of oil in 100 kilograms per cubic meters. Density ng water is 1,020 kilograms per cubic meters. So required ay yung height ng oil or H sub O. Para makuha yung H sub O, so yung pressure sa point C ng water at yung pressure sa point C in terms ng oil, so equal sila. Dun sa same elevation, different fluid, so equal yung pressure. So, pressure nga is unit weight times yung head or pressure head. Dahil given yung mga density, so in terms of density yung gagawin nating equations. So, ito yung mabubong equation. So, density ng water, 1,020 times yung acceleration due to gravity. Hindi rin nabanggit sa problem, so 9.81. Times yung 40 meters na nasa figure, which is equal to, doon naman sa part ng oil, so 900 kilograms per cubic meters. Times yung acceleration due to gravity para maging unit weight. Times yung H sub O, yung inahanap na height ng oil. So therefore, so 1020 times 40 na lang dahil cancel 9.81 over 900. So therefore, height ng oil ay 45.333333 meters. Problem number 3. The soaking bin contains ethyl alcohol used for cleaning automobile parts. Suction pump C is to vary the pressure trapped air in the enclosure B. If the pressure in the trapped air is P sub B, which is equal to negative 5.50 kilopascal, so negative dahil nga suction, no? Suction pump yung nasa point C. Determine the pressure developed at point A and the height each of the ethyl alcohol level in the bin. Use a density ng ethyl alcohol, which is equal to 789 kilograms per cubic meters. So, ang kailangan yung pressure at A. So, ang pwedeng mag-cause ng pressure sa A, pwedeng sa left side niya, yung suction ng pump C, tapos yung height ng oil sa ibabaw ng point A, o kaya naman yung sa right side, pwedeng yung height ng oil sa right side, which is H minus 0.5. So pressure at A, and the height of ethyl alcohol H. So dahil hindi mo pa alam yung sa height ng ethyl alcohol H, so doon tayo sa left side, yung may suction pump at C. So pressure at A equals sa pressure at B, or yung air dun sa B, plus yung unit weight times yung height ng ethyl alcohol dun sa over A, which is 2.5 minus 0.5. Dahil given is density, so in terms of density, so unit weight is equal to rho times g, or density times acceleration due to gravity. So substitute yung mga nasa given, so therefore, so negative 5.5, dahil kilopascal, so times 10 raised to 3, plus 789 times 9.81 times 2. So therefore, pressure at A, so store ko na lang sa A, ay 9980.18 pascals. So para naman sa height ng ethyl alcohol H, so pressure sa A, so unit weight ng ethyl alcohol, dahil density yung given, so rho g, or density ng ethyl alcohol times acceleration due to gravity times yung sinabi nga na height kanina ng ethyl alcohol sa right side, which is H minus 0.5. So nasolve na yung pressure sa point A, given yung density ng ethyl alcohol, at yung acceleration due to gravity, 9.81, so masasolve na yung height ng ethyl alcohol H dun sa right side ng figure. So, divide both sides ng 789 tsaka 9.81, tapos add both sides ng 0.5. So, therefore, H is equal to ito. So, yung nakastore sa A over 789 times 9.81, then plus 0.5. So, therefore, height ng ethyl alcohol H ay 1.7894 and so on meters. Problem number 4. The filled storage tank is filled with water to the level shown. The standpipe is connected to the tank at B, and the system is open to the atmosphere at C. Determine the maximum pressure in the tank and the height H to which the water will rise in the standpipe if the pressure of the trapped air in the tank or the space at A is 65 kilopascals. So, kailangang makakuha ay yung maximum pressure tsaka yung height H. So, kung napansin nyo sa figure kanina, yung nasa loob ng tank or ng bin ay suction, so negative pressure. So yung nasa right side, mas mababa yung level ng ethyl alcohol. So dito naman, dahil mataas yung pressure dun sa inside the tank, so positive pressure. So yung nasa right side naman na open sa atmosphere ay mas mataas yung level ng fluid dun. So dito yung water. So kailangan maximum pressure. So para makuha yung maximum pressure dun sa lowest point, so Pmax and height H dun sa standpipe. So maximum pressure ay pressure sa point B. So pwedeng dahil dun sa tank, pwede natin makuha, or dun sa standpipe. So dahil wala kang value ng H para dun sa height ng fluid sa standpipe, so dun tayo sa tank, given ng pressure dun, yung pressure A, tsaka yung height ng fluid, which is 2 meters. So pressure plus yung gamma H, yung pressure induced ng fluid dun sa tank, which is yung water. Kaya unit weight ng water times 2 meters. So 65 kilopascal yung pressure sa A, sa space A, plus yung 9.81 kilonewton per cubic meter. So hindi given yung unit weight ng water, so ito yung gagamitin, times yung 2 meters yung height ng water. So 65 plus 9.81 times 2, so therefore maximum pressure ay 84.62. So store na lang sa A. And then para dun sa height ng water sa standpipe, so dahil nga same sila ng pressure, so dahil na-compute yung pressure, maximum pressure, equal din yun sa pressure at point B, which is equal to unit weight ng water times yung height ng water sa standpipe. So 84.62 kilopascals, which is equal to 9.81 kilonewtons per cubic meter times yung height ng water sa standpipe. So 84.62 nakastore sa A over 9.81, so therefore height ng water sa standpipe ay 8.6258 and so on meters. So problem number 5. At the bottom of a bubble within carbonated water has a diameter of 0.2 millimeters. Determine the bubble's diameter when it reaches the surface. The temperature of the water and the bubble is 10 degrees Celsius and the atmospheric pressure is 101 kilopascals. Assume that the density of the water is the same of pure water. So, bubble's diameter at the surface, so D sub S. So, dahil isothermal, so same temperature, Kaya based on sa ideal gas laws, ito yung formulang pwedeng gamitin. So P1 V1 is equal to P2 times V2. So P1, initial pressure is yung pressure sa bottom, which is equal to atmospheric pressure plus yung gauge pressure na unit weight ng carbonated water times yung height or yung depth mula dun sa surface. So, given yung atmospheric pressure na 101 kilopascals, unit weight ng water, so ang sabi yung carbonated water, same density ng pure water, so assume. So, 9.81 kilonewtons per cubic meters, multiply dun sa depth mula dun sa free surface, which is 0.3 meters. So, 101 plus 9.81 times 0.3. So, therefore, P1, so store na lang sa A, so 103.943 kilopascals. Para naman dun sa initial volume, V sub 1, so 4/3 pi r sub 1 cube. So 4/3 pi r cube dahil nga spherical yung bubble. And then given yung diameter, so divide sa 2 para maging meters. So 1 meters over 1,000 millimeters and then cube. Para mas maging madali, tama yung maging unit dun sa final answers. So therefore, 4/3 times pi times 0.2 over 2 times yung 1 over 1,000 and then cube. So therefore, initial volume, so store na lang sa B. So final pressure is atmospheric pressure lang. So therefore, P sub 2 is equal to 101 kilopascals. And then yung final volume, so nandito yung magiging final answer. So, kailangan yung bubble's diameter when it reaches the surface. So, V sub 2, so 4/3 pi r cube din. And then yung radius, so D over 2. So, P1 V1 is equal to P2 V2. So, substitute sa equation yung mga na-compute na values. So, divide both sides ng 101 kilopascal. Tsaka yung 4/3 pi. Tapos yung sa may expression na D sub 2 over 2, so 1 over 2 cube na lang. Tapos cube root na lang. So, 103.943. Tapos yung nakastore sa B. Tapos 101 times 4/3 pi times 1 over 2 cube. And then cube root. So, 1 over 3. So, therefore, bubble's diameter when it reaches the surface ay 0.0020192401 meters or 0.2019 millimeters. So, mas malaki lang ng konti. Problem number 6. Determine the following. Maximum pressure in the system, pressure at B, tsaka pressure of the trapped air in the closed container. The containers are filled with water. So, P sub max or maximum pressure, pressure sa B, tsaka pressure ng air. Para makuha yung maximum pressure, yung nasa lowest point, which is point A. So, pressure sa A is equal to gamma H. So, 9.81 times yung depth mula dun sa free surface or yung depth ng water ay 3 tsaka 0.5. So, 3.5. So, therefore, 9.81 times 3.5. So, 34.335 store lang sa A. So, yun yung maximum pressure. So, pressure sa point B, so gamma H din. Then, 9.81 times 3 meters lang. So, 9.81 times 3. So, 29.43. So, store na lang sa B. So, 29.43 kilopascals. At yung pressure ng air dun sa closed container, which is equal to pressure sa point C. So, pwedeng yung same elevation dun sa tank na may point B mula dun sa free surface niya, katapat ng point C. So, 9.81, so gamma or unit weight ng water times 3 minus 1.5 para dun sa point C. So, 9.81 times 1.5 na lang. So, 14.715 kilopascals yung pressure ng air dun sa closed container. Problem number 7. Determine the difference in pressure, P sub B minus P sub A between the centers A and B of the pipes which are filled with water. The mercury in the inclined tube manometer has the level shown. Use specific gravity ng mercury which is equal to 13.55. So, pressure B minus pressure A or difference in pressure sa point B at A. So first solution, so same level, same yung pressure. So dito, ang level na kinuha ko yung sa level na D. So left side, so pressure A, plus yung unit weight ng water, pababa hanggang C. So gamma H, so 0.100 meters, yung 100 millimeters, plus yung depth ng mercury. So pressure sa mercury, so gamma H din. So unit weight ng mercury times yung depth ng mercury na yun. So 0.250 minus 0.1. Tapos din sa right side, sa D, so pressure sa B, tapos bumaba, so plus unit weight ng water times 0.250. So, subtract both sides ng unit weight ng water, tsaka ng 0.25, tsaka ng pressure sa point A. So therefore, substitute yung mga given, tapos yung unit weight ng water, hindi sinabi, so 9.81. Tapos yung specific gravity ng mercury, so 13.55. So 9.81 times 0.1 plus 13.55 times 9.81 times 0.15 minus 9.81 times 0.25. So therefore, difference in pressure between points A or points B and A, so 18.4673 kilopascals. So isa pang solution, pwedeng yung galing sa left papunta sa right. Kapag bumaba yung point, so plus. Tapos kapag tumaas naman yung point, so minus. So mula dun sa A, tapos bumaba ka hanggang point C, so plus yun. Tapos bumaba ulit yung papunta sa point D, so plus ulit. So unit weight ng mercury, 0.25 minus 0.1. Tapos papunta sa B, so tumaas ka mula dun sa D, so unit weight ng water times 0.25, which is equal to dun na sa pressure sa B. So same din ang equation, so same din na magiging sagot. Problem number 8. Butyl carbitol used in the production of plastics is stored in a tank having a U-tube manometer. If the U-tube is filled with mercury to level E, determine the pressure in the tank at point B. Use specific gravity ng mercury, which is equal to 13.55, and specific weight ng butyl carbitol, which is equal to 0.957. So, ang kukunin ay yung pressure sa point B. So, gamitin natin yung pangalawang solution sa concepts ng manometer. So, galing sa B, so pressure sa B, dahil tumaas ka ng 0.25, so minus, unit weight ng butyl carbitol. Dahil bumaba ka ng 0.05 or 50 millimeters, so plus. And then, dahil tataas ka mula sa point D, sa elevation D, pupunta dun sa pinakaibabaw, sa point E, so level E, so minus gamma H. So unit weight ng mercury times 0.12, which is equal sa pressure sa E. At yung pressure sa E dahil open, so 0 yung value nun. So yun nga yung pressure sa E plus 0.957, yun yung specific weight ng butyl carbitol. Tapos 9.81 para dun sa unit weight ng water. Hindi rin sinabi, so ito yung gagamitin. Tapos minus, yun din sa butyl carbitol yung pagbaba. 9.81 plus 13.55 times 9.81 times 0.12. So 9.81, so nilabas ko na lang 0.957 times 0.25 minus 0.957 times 0.05 plus yung 13.55 times 0.12. So therefore, pressure sa B is equal to 17.8286 kilopascals. Problem number 9. Assuming the specific weight of air to be constant at 12 newtons per cubic meters, what is the approximate height of Mount Banahaw if a mercury barometer at the base of the mountain reads 654 millimeters? So at the same time, another mercury barometer at the top of the mountain reads 480 millimeters. Use specific weight of mercury, which is equal to 13.6. So ito yung magiging illustration nun. So sa bottom, so yung pressure. So in terms of millimeters mercury, so 654. So pressure is 654 millimeters mercury. Tapos yung pressure sa top is 480 millimeters mercury. So para makuha yung height H, so pwedeng concept din ng kagaya sa manometer. So pressure sa bottom, tapos tumaas ka, so minus gamma H, which is equal to sa pressure sa top. So pressure sa bottom, so unit weight ng mercury, so gamma H. So gamma H equals sa gamma H. So, substitute lang. So, para makuha yung unit weight ng mercury, specific gravity, multiply sa unit weight, 13.6 times 9.81 times 10 raised to 3, plus 0.654. Yun yung in terms of mercury, kaya naka-millimeter, so 0.654. Minus yung unit weight ng air, so 12 times H. So, yung 9.81 times 10 raised to 3, so kilonewtons yun. So, dahil yung isang given is naka-newtons lang, so in terms of newton na lang yung pag-solve. And then equals at ganun din, so 13.6 times 9.81 times 10 raised to 3, tapos yung height ng mercury, so 0.480. So, millimeters, or the pressure head in terms of mercury ay 480 millimeters. So, subtract both sides ng 13.6, 9.81 times 10 raised to 3, tapos add both sides ng 12H, and then divide both sides sa 12. So, substitute na lang. So, 13.6 times 9.81 times 10 raised to 3. So, 0.654 minus, and then 13.6, 9.81 times 10 raised to 3 times 0.48 over 12. So, therefore, H is equal to 1934.532 meters. Problem number 10. A pressure gauge at elevation 10 meters at the side of a tank containing a liquid read 80 kilopascals. Another gauge at elevation 4 meters reads 120 kilopascals. Find the specific gravity of the liquid. So, specific gravity yung kailangan. So, pressure at elevation 10 meters, so 80. As elevation 4 meters, so 120 kilopascals. So, dahil bumaba, so may liquid ka sa pagitan ng elevation 10 at elevation 4 meters. So, from 10, dahil bumaba yung pag-measure dun sa pressure, so plus. So, plus gamma H. So, gamma unit weight ng liquid times yung H yung difference in elevation. So, 10 minus 4. Which is equal to dun sa pressure at elevation 4 meters. So, substitute. So, 80 kilopascal. So, yung unit weight ng liquid, specific gravity times 9.81. So, naka-kilonewton to lahat. So, 9.81 lang. Tapos, 10 minus 4, so 6, equals sa 120. So, 120 minus 80 over 9.81 times 6. So, therefore, specific gravity ay 0.6795 and so on.